comet Dennin-Fujikawa appears about every 9 years. Well, it wouldn't have been last seen in 2005. The textbook's getting old already, right? Because if it's every 9 years, let's write it out. You have 2005, then 2014, then 2023, and so on. Did anyone see it in 2023? Or was it, maybe it was cloudy. Maybe it actually last was seen in 2005 because it was cloudy. It could, but this could still be true and not just that the textbook is slowly getting outdated. Don't know. And the question is if it continued, right? So, hey, you can put this on your bucket list. Look at this. Right? 2032. Put it on your iCalendar already. Plan for it. Take the year off of work. You're going to see if you can see this comet. Right? You can plan for that. But if all of a sudden you miss it in 2032 and you become immortal, because this could possibly, who knows? Lots of changes. Like AI didn't exist 5 years ago. Immortality might be just around the corner. We don't know. So the question is, could you see it in the year 3085, right? If you all of a sudden became immortal and added this to your bucket list, things you wanted to do before you, I guess, never died, as a possibility. Okay. So what is this question asking? It's asking if this is a term. Is there actually a number that makes this work? Does it make sense then that we need to find n? Because where that question mark is, what we don't know is where the n would be. We need to find n, and n has to be a whole number. It can't be 85.2. Because if it's 85.2, it's not in the sequence. So a whole number, here's some notation-wise, right? N has to belong, remember the symbol for all your natural numbers? Right? So our n has to be a whole number in order for this to work. So let's go to our formula sheet. Our formula sheet says, if it's an arithmetic sequence, this is your general term. What do we know? Well, we don't know n, but we know that the term that we're looking for is supposed to be 3085. This lets us replace the Tn with 3085 even though we don't know n. Because if we look at our sequence, right, we don't know the question mark, but we know what it's supposed to equal. It's supposed to equal 3085. So I can plug in 3085 for Tn. I know term 1 is 2005. I know my common difference is every 9 years, but I don't know n. Brackets out in front, you could distribute this. Should give you 3085 equals 2005 plus 9n minus 9. We have some like terms here, the 2005, the minus 9, and the 3085. Those are all like terms, so I'm going to put them all on the left-hand side of my equation here. So I subtract 2005, I add 9 to this side, and I get 1089. And I can divide both sides by 9. And it does work out to a nice number. Right? This is not a decimal. So we can say, yes, it will appear in the year 3085. So if you happen to be alive at that time, hey, something you could do. Yeah.
Would you be calculating for questions?
Yes, this would be a calculator just because, like, you're not expected to do 1,089 divided by 9 in your head. And sometimes they'll work out to a decimal. So if it had come to 121.3, then you would say, no, you're not, it's not a perfect number. It's not in the sequence. So it won't appear in that year. Okay, questions to put at the top on this one? Question number 14, circle number 14.